So this is exponential and logarithmic application. So we're just going to do a bunch of word problems and then solve them just like in the last video. So our learning target is I can solve application problems. Alright. So we're going to look at 2 to begin with. So Mark started a new blog to write about his travels. In its initial week, the blog had 800 readers. From this point, the number of readers increased by 25%. Use an exponential growth model to find the week in which the number of visitors reaches 10,000 people. So 2 different things going on. You can go back and watch those videos about growth and decay. This is actually from Math 1 and Math 3, I think. So here's what they look like. Exponential growth function looks like this. Okay, and then a decay model would look like this, 1 minus r. So A is your starting amount, R is your rate changed to a decimal, and T is your time. So we talk about Mark having an initial blog that had 800 readers, so A is 800. 1 plus, the rate was 25%. When you change 25% to a decimal, it becomes 0.25. And then T is your time. So we're trying to figure out when it's going to actually equal 10,000. So I'm just going to make this a little prettier. I'm going to go ahead and add 1 and 0.25 together, so I get 1.25. Okay, so what I'm trying to do, just like in that last video, is isolate this part. So I'm going to get rid of the 800 by dividing. And I get 12.5. Okay, this is in exponential form. So what I'm going to do is, you could either take the log of both sides, or you could just put this into log form. Let's do log of both sides. So I'm going to log this side. I'm going to log this side. Remember that anytime you have an exponent, you can move it to the front of the word log. So I have log 12.5 equals T log 1.25. I'm trying to get rid of the stuff beside of T, so I'm going to divide both sides by log 1.25. So in my calculator, I'm going to type the log of 12.5 divided by the log of 1.25, and I get 11.3. So I would say 12 weeks. Alright, so that's how you do that one. Alright, so the second one, a new stock entered the stock market in January 2012 at 0.72 per share. 4 years later, the price per share was 3.85. Using a continuous exponential growth model, find the growth rate. So I don't know if you remember this, but anytime it talks about continuous growth, that is your PERT formula. Alright, so A is your ending amount, P is your starting amount, E is the number E, R is the rate changed to a decimal, and T is time. Alright, so it ended at 3.85. It started at 0.72. We're trying to find the rate. We don't know that, but we do know 4 years have passed. Okay. So really, it should look like this if you're going to write it mathematically correct. You put 4R. Alright, so just like the last video we watched, we're going to isolate the E to the 4R. So I'm going to divide both sides by 0.72. So I get 5.3. My decimal never wants to work. Okay. Equals E to the 4R. I'm going to log both sides, but remember, because I have an E, I'm going to do the natural log of both sides. Alright, natural log and E always cancel each other out. and then the last thing is divide by 4. So in my calculator, I'm going to do the natural log of 5.3472 divided by 4, and I get 0.4191. So remember, the problem asks about what's the growth rate, so if I change this to a decimal, it would be 41.91%. So that would be the answer I'd be looking for on a quiz or a test. Okay, so this is a lot to review from Math 1, Math 2, and Math 3, because remember you're in Math 4. And then we're using the stuff we reviewed in solving to go back and actually figure out how to do these. Okay, so a certain medicine has a half-life of 5 hours. If a patient is given 500 milligrams at noon, at what time will they have 100 milligrams remaining in their bloodstream? All right, so it always equals what you end with. It's going to start with 500. We're talking about half-life, so we're talking about half. And I don't know if you remember the half-life formula, but it's always x divided by the half-life. So the half-life is 5 hours, so I do divided by 5. Okay. So pretty much the same thing. I'm going to isolate this, so I'm going to divide both sides by 500. Okay, I'm going to take the log of both sides. Remember that anytime I have an exponent, I can move it in front of the word log. Okay, so I'm going to get rid of the log 0.5 by dividing both sides. Alright, so I'm going to round to 2 decimal places at least. And then the last thing I have to do is to get rid of dividing by 5, I'm going to multiply both sides by 5. So I get x is 11.6 hours. So the question asked me at what time, so my answer would actually be 11:36 p.m. But if you could just come up with this, I will totally count that on a test or a quiz. Okay, so this is brand new stuff. This is a logistic growth application. So unless you just do some math in your own time, you've probably never seen logistic growth. The nice thing about this one is you don't have to memorize any formulas. So we're just going to read it carefully together. The growth of a plant can be modeled by the equation below, where h is the height of the plant in centimeters and t is the number of weeks since the seed was planted. So how many weeks will it take the plant to reach a height of 50 centimeters? So we know that we can replace h with 50. It never wants to do the decimal. Okay, so this is what we have, and what we're trying to do is get t by itself. So the first thing I could do is notice that I'm dividing by this entire parenthesis. So to get rid of division, I can multiply both sides by that entire parenthesis. Alright, so let me write what I have on the left side. Make this a little easier. Alright, so remember on the right side, these cancel out. That was the whole purpose of doing this. Okay. And now what I'm going to do is I'm still trying to get t by itself right here. But I'm going to start getting rid of some stuff. So I'm going to get rid of the 50 by dividing both sides by 50. Alright, so I get 4. I'm going to get rid of, oh no, so I get 5, my bad. 5. I'm going to get rid of the plus 1 by subtracting. I'm going to get rid of the 12 by dividing. Alright, and now remember that the way we get rid of an e is to take the natural log of both sides. So when I do the natural log of e, remember that cancels out. That's the whole point. So I have negative 0.72t equals the natural log of 1/3. And then the last thing I want to do is divide both sides by negative 0.72. Negative 0.72. So I get that t is equal to 1.53. Or you could say 2 weeks if you just want to round it up, because it did ask how many weeks. Okay, and then we'll do the next one pretty much the same way. So a small lake is stocked with a certain species of fish. The fish population is modeled by the equation below, where P is the number of fish in thousands, and T is the number of years since the lake was stocked. So how many years will it take the fish population to reach 6,000? All right, so it's nice that they give you these formulas so you don't have to worry about these. Okay, so remember that P is in thousands, so I'm just going to replace P with 6, because 6 thousands is 6. Okay. So pretty much like that last one, the first thing I'm going to do is I'm going to multiply both sides by 1 plus the quantity 1 plus 3e. Okay, the next thing I'm going to do is I'm going to divide both sides by 6. So 8 divided by 6, let's see, 4/3. I'm going to subtract 1 from both sides. I'm going to divide both sides by 3. Alright, so remember that the way you get rid of an e is to take the natural log. And when you take the natural log of that left side, the e cancels out. So this is what you have. And then the last thing I'm going to do is divide by negative 0.7. So you should get that 3.14. Remember, this is talking about how many years, so if you wanted to say or 4 years, that's perfectly fine. Okay, so this is just, it's just solving problems like we looked at in the previous video, but you're just reading a formula to figure out where to put stuff. It's not that bad, not that bad. Okay, so then let's review some compound interest, because everybody loves that. Woohoo! Alright. Okay, this one is a tough formula, so let me write down the formula. Okay, so A is the ending amount, P is the starting amount, 1's just the number 1, R is rate changed to a decimal, N is the number of times you're compounded in a year, and T is time. So this is a lot. If 500 is deposited, so that's your P, into a retirement account that pays an annual interest rate of 4%, so I'm going to change that to a decimal, compounded quarterly, there are 4 quarters in a year, how long will it take to reach a balance of 1,200? Okay, so that's how we do this. The first thing I'm going to do is I'm going to take the stuff in the parentheses and I'm going to just make that one number just so it looks a little prettier. But that's just me being OCD. You do not have to do that. Okay, so now, remember I'm trying to isolate this part. So I'm going to divide both sides by 500. So I get 2.4. Okay, I'm going to take the log of both sides. Remember that anytime I have an exponent, I can use the product property to move it to the very front of the log. I'm going to divide both sides by log 1.01. Alright, I'm going to put that in my calculator. 87.984. And then the last thing I'm going to do is divide both sides by 4. So I get that t is 22. Okay. So, it seems really confusing, but it's the same stuff as you did yesterday. Okay, so let's do the next one. Dave deposited $500 into a savings account. After 15 years, the account had tripled, so it's going to equal $1,500. Alright, so notice that this one talks about compounding continuous. So if you remember from Math 3, when you talk about compounding continuous, that's when you use the PERT formula. So anytime it says compounding continuous, you have to use this formula. So this is going to be E. We don't know the rate, but we do know the time is 15. So I'm going to rewrite it so it's a little mathematically correct. So 15R. Okay, so I'm trying to get E by itself. I'm going to divide 500 on both sides. So 3 equals E to the 15R. I'm going to log both sides. Remember, because I'm using an E, I have to natural log both sides. Remember, this cancels out. So natural log 3 equals 15R. And then I would divide both sides by 15. So when I type in the natural log of 3 divided by 15, I get 0.0732. Remember, the problem is asking about the rate, so if I change that to a percentage, it's 7.32%. So that's the answer I'm looking for. Okay, and then we'll do this last one. So this one, Scarlett invested $8,000 into an account that pays 7.5% interest per year, compounded continuously, which means you have to use this formula. How long will it take the account to reach 10,000? So 10,000 is what I end with. 8,000 is what I begin. E, I'm going to change my rate, and I don't know my time. That's what I'm trying to figure out. So I'm trying to isolate this, so I'm going to divide both sides by 8,000. 1.25. I'm going to take the natural log of both sides. Remember, I'm doing that because there's an E. These cancel out, which is nice. And the last thing I'm going to do is divide by 0.075. Ooh, that is a 5, yuck. Alright, so my answer is 2.975, or if you just wanted to say 3 years, that's perfectly fine. I realized that that was a lot of stuff to absorb. We used a lot of different formulas. Remember, this was stuff from Math 3, so if you need to go back and look at those videos from Math 3 and go back over those notes where I go over a little slower, you can do that. It's on Haiku. There's also extra credit stuff that you can do to bring your grade up, because I know that this class struggles with math, and if you already struggle with math and we're reviewing everything from Math 1, Math 2, and Math 3, there's a lot of places where you're like, what is she even talking about? So reach out to me. Let me help you. Do the extra stuff on Haiku. See if that makes sense. Do the extra credit so you don't fail the class. Lots of options so you could pass. You just have to put in extra work. Let me know what I can do to help. And I will see you later. Bye.